Hello, welcome to SUSE Manager at Scale Hub Architecture Do's and Don'ts. In this session, we will cover a hub architecture overview, use case scenarios where you should use the hub and where you should not use the hub, hub architecture design approach. How do you approach designing a hub when you've decided that you need one, and expanding from a single server scenario to the hub scenario, followed by a short Q&A. I am Anne-Marie Watrinka. I'm one of the technology consultants here at SUSE.
And hi, I'm Ricardo Mateus, and I'm a software architect and member of the SUSE Manager development team. So let's start with a review and overview about what the SUSE Manager architecture looks like and why do we need this in the context of SUSE Manager. So first thing, why do we need SUSE Manager Hub and why are we talking about this? So we know that with one single SUSE Manager server, we can manage up to 10,000 clients at the same time. But we are getting requests for managing bigger and bigger deployments with more than 10,000 machines, and that is complex to do with just one single SUSE Manager server. To do that, we need to deploy several different SUSE Manager servers to be able to scale the number of machines that you can manage. And for that, we came up with the Hub deployment architecture, which is basically a deployment blueprint to support big scale environments to be managed with SUSE Manager. We should look at SUSE Manager Hub server as a server of servers. So one SUSE Manager server that is responsible to manage other SUSE Manager servers, plus a set of tools to help the operators to be able to manage all these environments. We should think of this hub as an umbrella term that basically joins all these concepts in one single term to be able to manage this kind of deployments. This is an example of a deployment architecture of the hub. We can think of the top level SUSE Manager server, which is responsible to manage the lower level SUSE Manager servers. So a central point of management is this infrastructure. And then the low level SUSE Manager servers, which where we can register our machines and our proxies to manage all our architecture. In the top level, we can make some management of the content that we want to make to our environments, and you can have a central place to manage all the content and all the information that you want to keep current between all the lower level SUSE Manager servers. To differentiate between these two levels of servers, you need to name it somehow. So we call the top level the SUSE Manager Hub server, and the lower levels, we call them the SUSE Manager peripheral servers. But as said before, this is also the SUSE Manager Hub is also composed with a set of tools to help managing this complex infrastructure. And the first one is the inter-server sync. So the goal of inter-server sync is to synchronize content between different SUSE Manager servers. So we can define the content on the top level one, the hub server, define which channels we want or which configuration channels or which images. And as soon as we are happy with the content of these software channels or configuration channels or images, we can synchronize them to the peripheral servers, the low level ones, and make sure that the same content are present in all the peripheral servers and all the content are exactly the same. The second component that I would like to present you is the Hub XML RPC API. So this is a central piece of the Hub deployment because it provides one central API where you can call the exact same methods that exist in the existing XML RPC API from the SUSE Manager server, but you can call it in a central place. So with this central place, all the calls that are made to this Hub XML RPC API are then broadcast to all the peripheral servers that are connected to the Hub server. And in this way, in one single pane of glass, you can propagate the calls to all the peripheral servers and also is responsible to collect all the replies and return back to the users and avoid the need to connect to each one of the peripheral servers and make the calls to collect all the information that is needed. The last component is the unit configuration modules. These are a set of salt modules and formals with forms, which can be installed in the hub server and allow you to configure the SUSE Manager peripheral servers in a coherent way. And with these modules and formals with forms, you can configure, for example, organizations, you can configure users, activation keys, and even system groups. And in the same way, also make sure that all the same information are present in all the peripherals in a consistent way. Some of the benefits of the hub server are, as I said before, manage large scale environments, so more than 10,000 machines, and also provides a way to have a central content management, so you can have software and configuration channels managed in the hub server, and this content copied to the peripheral servers, organization, system groups, and activation keys. It also provides a report federation, so the report capabilities that SUSE Manager already has. It's also present in the hub, and the hub has the ability to federate all the reports that exist on the peripheral servers and provide all this information in a single location in the hub. And you can have information like all the systems that exist in our inventory, or some security checks that you can verify that if the systems are affected by any CV. And you can also provide a single point of interaction through the Hub XML IPC API when you can broadcast the calls to all the peripherals through the hub. However, we need to be aware that hub deployment also increases the complexity to manage your systems. So you have more SUSE Manager servers to manage, even if the hub gives you some help on that. So we should not use it when it doesn't, where we don't need it, or where it's not needed for the deployment that you are trying to achieve. Okay, so we need to be careful on when to use it and where not to use it. Now it's time to look at some hub use case scenarios and on where to use hub and where not to use the hub. So let's start with one that is the simplest one. So manage a small number of machines, and all the machines are part of the same organization. In this case, well, you don't need to use the hub as expected, because you can just use one single SUSE Manager server that can be able to manage all these machines in just one instance. One example of this is to manage the SAP HANA installation with 10 machines, for example. Okay. So the second scenario is if you want to manage up to 10,000 machines, and we know that the number of machines that you want to manage will not grow in the future. So we are not expecting to have more than 10,000 machines on this environment. Because if you are expecting more than this number, then we should look at the next scenarios and prepare for this expected growth. In this scenario, we are expecting that some machines can be managed independently inside the same company. So different groups of users managing different groups of machines. But we still want to share some content between this group of machines that are managed. In this case, you also don't need to use the hub because you can offer other deployment solutions. One example is to use a single SUSE Manager server, but with multiple organizations configured on it. One example of this deployment is a company with several departments, and you want to have some separation between each department and each machine on each department. So, and different groups of users that needs to manage these machines. Okay, a third scenario is if you want to manage a large number of machines. So let's consider a large number, more than 10,000 again. But we know that these machines are managed independently, so no relationship between the machines in different groups. So we can have more than one group that doesn't have a direct relationship between them, but each of these individual groups have less than 10,000 machines registered to it. Also, in this scenario, we don't have any need for content sharing, and we have completely different content management policies, and also potentially different set of user administrators to take care of this group of machines. In this case, you also don't need to use the hub. Okay, you can can deploy multiple SUSE Manager servers and manage these machines independently, and basically have one SUSE Manager server deployment per logical group. And what can be this logical group? We can provide some examples. For example, you can have one SUSE Manager to manage all the SLE operating systems and all the SLE machines in one independent SUSE Manager server with its own update policies and its own defined content. And you can have a completely independent SUSE Manager server to manage the CentOS machines with different users, with complete independence between these two deployments. One more example is if you have, for example, one update policy for EMEA and another update policy for APG. So in here we are separating the machines or the minions by geographical location, and they are connecting to a different SUSE Manager server if they are in one location or the other. But if they have completely independent update policies and users to manage, this can be two different SUSE Manager servers and be able to manage the same way but without overhead of hub. So one more use case on this one. Managing a large number of machines, so more than 10,000 machines, but you need a central management platform, so something that you can manage all the content centrally and make sure that all the machines have the same update policies across your landscape. In this case, do it. You should use the SUSE Manager HUB for it. Okay, it's the best approach for you. And one example for this is several data centers across the globe that needs to share the same update policies across all locations. We can look at this diagram to make it more clear. In this case, you have a SUSE Manager Hub server where you can configure your peripheral SUSE Manager servers and you can define your content. As soon as you are happy with your configuration and software channels and so on, you can copy all that content to the peripheral servers in each one of the offices or each one of your locations, and then update the minions that are connected to this local office. In this example, you have an office in New York with one SUSE Manager server that manages all the machines in this office, and you have another office that is located in Munich with another SUSE Manager server that is also responsible to manage all the machines in this Munich office. This way you can have a central place to manage all the content and make sure that both SUSE Manager servers have exactly the same content to be applied to the minions that are registered to them. Okay, in the last scenario, it's a retail where with several locations, we are managing a large number of endpoints, so again, more than 10,000 machines, and all machines share exactly the same content policy or really close content policies. And in this case, yes, please use the SUSE Manager HUB deployment architecture. And well, again, one example for this is a retail scenario. Here is a diagram exposing this. So you can have a SUSE Manager HUB server, and you can register a machine to that, which is the image builder that is responsible to build our images for your terminals. You can build these images right in the hub. You can test it and verify if the image is according to your standards and everything is as expected to be. And as soon as you are happy with that, you can copy that image to each of the SUSE Manager servers that are connected to the hub, the peripheral servers, and then those SUSE Manager peripheral servers are responsible to basically roll out this new image and install that in the desired terminals and connecting to the branch servers and so on, and use the normal retail scenario and propagate all the content again in a central location and make sure that the same image is spread across all the peripheral servers. Okay, moving forward.
Hub architecture design approach. How do you approach the hub design once you have decided that this is the right architecture for you, based on the examples that Ricardo discussed in the previous section? Well, step one is to identify the type of environment that you're working with. Is it retail? Is it not retail? Are there multiple geolocations involved? Step two would be to review the scale of the environment, namely how many servers are we going to manage with this architecture. Step 3 would be to identify the desired mapping between the endpoints and the peripherals, and actually deciding how many peripherals we want. Step 4 will be to identify data on the endpoints that are going to help us with programmatically onboarding systems, as we will want to do that in an automated way. And step 5 will be to plan for potential significant architectural growth of the environment, not the day-to-day system additions that would require us to just spin up a new server in a particular data center or open up a brand new retail store. But but architectural growth that is on a larger scale. For example, if you are a retailer and you're purchasing another set of chains stores, and you know that you're going to have thousands or tens of thousands of more servers that will be managed by this architecture in the future, or that you will want to manage using this architecture in the future. So why is this endpoint and peripheral mapping or to peripheral mapping important? So first of all, there will be no single pane of glass for the web UI on the hub server. You will be able to send remote commands and perform actions such as batching or rebooting or configuration management using the XML RPC API from the hub. But in the hub server, you will only see registered the other peripheral servers. And subsequently, on each peripheral server, you will only see the registered systems that are registered to that particular peripheral server. So if you decide that you're going to use 10 peripheral servers, if you log into each of them individually, you will only see the systems that are registered or that have been mapped to that particular SUSE Manager peripheral server. This mapping is important because we want to decide how to organize our systems. We want to decide how many peripheral servers we want. And we also would like to speed the onboarding of this system. So once we decide this mapping, this is going to help us with the speed of implementation for onboarding all of the servers in a programmatic way to the right peripheral that they should go with. This automation is also a good established practice for onboarding any additional servers post-implementation. So for example, we've built the code, we've onboarded all of our existing servers, whether it's retail or whether it's data center servers, and then we have to spin up one more store or one more server based on if we use this automation practice based on our server naming convention, for example, we could just reuse that automation script to spin up a new server and then onboard it to the appropriate peripheral. We also want to build that methodology or that automation so that we have an expendable methodology for future growth. So for example, we are managing a set of Linux distributions right now, and a new service pack comes out, or a new operating system is introduced into our environment, or a new hostname naming convention, or some component that we've used for the automation has now changed. So we want to build this as in such a way that it's expandable, so we can always add more criteria to our automated onboarding methodology and expand it in the future. So thinking out how we're going to do that ahead of time is important. That is going to help us develop it in such a way that it's easily expandable. We also want to consider network proximity to a management server. So whether there's a peripheral server where we're registering to, or we're registering to a branch or a proxy server, then we will want to register our systems to the nearest server in proximity. And that is for obvious reasons. You don't want to traverse the network across the ocean to register to management server that is far away from where the endpoint is located. Now, one of the examples is a data center with multiple geolocations. So let's say we had such an example where we have three geolocations in Munich, New York, and Amsterdam. Each of the geolocations has approximately 5,000 endpoints per location, and our server naming convention can easily map the location of the system to its physical or geographical location, because we have given our servers a naming convention such that NY stands for New York, AM stands for Amsterdam, and MU stands for Munich. The second, or the next three letters in this example stand for the app. The following letter stands for the environment, whether it's production, development, or test, and then we have an instance number 01, 02, 03. So in this situation, our target architecture would look like this. It would be a hub server located in one of the data centers. We would have three peripheral servers located in each data center in proximity to their managed endpoints. And the automated onboarding process design will use the first two letters in the hostname to identify the appropriate peripheral to register those systems to. And this example is quite easy, but what happens when you don't have a server and hostname naming convention that can help you identify that this is a server from New York, for example? Well, you don't have to use naming convention or of the host name. You can use IP addressing or anything in your environment that you use or that you use to know that this server pertains to that geographical location. Another thing to consider is that even though these approximate 5,000 endpoints are mapped exactly to the three different geolocations, there might be a situation where I have 6,000 or 7,000 endpoints in New York and only 3,000 in Munich, right? So you don't have to distribute the load in such a way that it has to be exactly the same. It really does depend on your environment, but you can keep in consideration the fact that one SUSE manager can manage up to 10,000 systems. A second example talks about a retailer with multiple edge locations. So in this environment, we have 1,000 retail locations with 10 servers and 10 registers per location, plus the one mandatory branch server that we need for SUSE Manager for Retail to deploy the register images and manage the registers on site. We have 30 lab stores. We have 500 corporate servers. And as we can see below, our sample corporate server naming convention differs from our store server naming convention. So in this example, our target architecture is going to a hub server with 6 peripheral servers that are all at a central location. We've decided that peripheral 1 is going to manage all the lab stores, even though there are only 630 systems. And our peripheral 2 is going to manage all the corporate servers, even though there's only 500 of them, just because we want to keep them separate from our production stores. And our peripheral 3 is going to manage stores ending with numbers 0 to 3. And our peripherals 4, 5, and 6 are going to manage stores ending with digits 4, 5, 6, 7, and 8, 9, respectively. So our automated onboarding process is going to actually use the hostname naming convention to identify which are corporate stores. For lab stores, you might use hostname naming convention or some other methodology, like, for example, if these lab stores are sitting in this IP subnet, then I know they're lab stores. Or they might have a host name that starts with a particular number that tells the environment system administrators, which are the lab stores. And the production stores will be mapped using the store number convention, right? So this, again, depends on your environment, and it may be different for everybody, and how you want to lay this out, and think about how you want to map to the peripheral servers, and decide how many peripheral servers you need in your particular environment. It really does depend on your the knowledge of your environment. So in this particular case, we also see that the stores ending with 0, 1, 2, and 3 are all mapped to peripheral 3. And that could be because we've done some analysis and we've counted them all out, and they add up to 5,000 servers altogether, and we didn't want to introduce yet another peripheral to split those apart. Again, this can be a decision depending on your analysis. Next steps in our do's and don'ts, especially when you're approaching how you want to design your hub architecture. I would say you want to invest most of your time in designing your deployment and distribution architecture. Decide how you want to map everything out. Find a logical mapping that works for your environment, and then build your custom scripts to onboard system using automation, as that's going to help you, get the use of this technology as quickly as possible. And engage consulting for help, as this can get a little bit complex. Don't worry about distributing the number of systems exactly the same to all peripherals. That is not required or mandated. Don't map systems to a management server that is far away in another geolocation. Don't be afraid of using more peripherals, as there's no additional cost per SUSE Manager. So you could have 10 peripherals if you need them, right? The only cost to having more peripherals is managing the content synchronization between the hub and these peripherals, and the cost of setting them up and managing them. So that is the only overhead. So expanding from a single server to a hub. So if you're not using this architecture at first, but let's say you have an environment where the amount of systems that you've added has grown to the point of 10,000 servers, you'll want to decide, when do I expand my architecture? So there are a number of things that you can ask. Are you close to 10,000 machines or even above? Is your business expanding significantly? And is your server experiencing a heavy load but already has been tuned for large-scale environments? So there have been some cases where even before the 10,000 endpoint mark, there are some use cases that have experienced a huge load on a SUSE manager because of the methodology in which the customer is using it. So there are cases where you don't necessarily need to exceed the 10,000 machine mark to introduce the hub architecture, although they may be one-offs, right? So at this point, if you are experiencing a heavy load, or you expect that your business is going to grow significantly, you can always engage us for help to discuss what your options are and what makes sense for your environment. It could be that you introduce another instance of SUSE Manager, but not necessarily use the hub architecture. It really does depend on your use case, and we can help you decide that. But if you do decide, or if it is required that you expand from a single SUSE Manager server to a hub architecture, what we typically recommend is to build new and migrate. And the reason there are multiple reasons for that, but this is a good opportunity to reorganize the environment through that mapping exercise that we've discussed earlier. So one way or another, you have to redistribute the load of systems that you have in your existing SUSE manager to some peripherals. So building a new hub, new peripherals, and then deciding on the mapping and then migrating to the new architecture is probably easier than trying to reuse the existing SUSE Manager instance that you have. So this actually also, there's an additional benefit is if you build out the new architecture, you get to redefine your content structure within SUSE Manager. So for example, if you have content lifecycle management projects or channel naming conventions that you currently use, now is a good time to look at those and ensure that maybe they make sense to our automated onboarding processes that we're going to use in the future, or we might want to adjust them now to so that we can make use of them as we start to automate the onboarding of the future, right? So we're going to have to redefine your onboarding standards or review and adjust at least, right? So this will also help us define more standards within the content structure of your SUSE managers that will be, for more automation adoption. And by this, I mean, because we're moving to the single pane of glass, non-web UI way of management, namely the XML RPC API used in the hub, now is a good time to think about the processes that you're currently using to patch your servers, whether they are used or heavily reliant on the web UI, and how you will be doing that using the XML RPC API in the future. So the opportunity to build a new architecture and migrate to that and redefine your content structure might better align to how are we going to use the XML RPC API to patch our systems in the future. And we will have to re-register all our minions to their respective peripherals either way, right? So even though all of this sounds complicated, the SUSE Manager Hub can help you scale, especially in very large and complex environments. So don't be afraid of using the hub. Again, there are no additional costs for SUSE Manager instances. The only work involved will be managing the content and synchronizing the content between all of these different instances of the SUSE Manager within the hub architecture. And that concludes our presentation. Thank you.